We have trig applications that we're doing today. Before we get to that, we are going to review again the parallel lines cut by the transversal. We have the zigzag, where we know all of those angles are going to be congruent, 1, 4, 6, and 8. And we also have the other zigzag, 1, 3, 5, and 7, where we also know that those angles are going to be congruent. Alternate interior angles is where we are alternating, going from one side to the other on the transversal. Interior means inside, and it's going to be inside this box that I have, which is inside the parallel lines. So we have two sets of alternate interior angles. We have angle 4 and angle 6, and we also have angle 3 and angle 5. All sets of alternate exterior, again, we're alternating, going back and forth on the transversal. Exterior is going to be outside of the parallel lines, and those are also going to be congruent, the same. 7, if you jump across to the alternate side, is going to go with 2, alternate exterior. We also have angle 8 and angle 1. Corresponding angles, you can imagine it that we have a set of angles here and a set of angles here. If you would imagine that they are cars, and the cars are sitting at a light, and both cars are going to drive this way. Corresponding angles is kind of like where they would be in the car. So for example, 2 would be like in our driver's seat. So angle 2 goes with the same spot in the other car. Who's in the driver's seat? 5. Passenger seat, we have angle 1. Who's in the passenger seat of the other car? Angle 6. Those are also corresponding. Same things for the back seats. If you have 8, and that's going to go with 4. And then we also have 3 and 7. And if you'll notice, those are also, whenever you look at each set, those are also going to be congruent, same, equal. For the next set, we are going to be talking about same side interior. For same side interior, it's going to be same side of the transversal, same side of that transversal. Interior, again, means inside the parallel line, so inside that red box. So same side, if I pick 4, who is on the same side of the transversal and inside the red box, it's going to be 5, angle 5. Those are not the same, they are supplementary, which means that they add up to 180 degrees. We could also look on the other side of the transversal. So if I have angle 3, who's on the same side and inside the red box, angle 6, and if you'll notice again, these are different colors, which means they are different measurements. You can see number 6 is acute, number 3 is obtuse. Those again are going to be supplementary, which add up to 180. For vertical angles, we're looking for that X. So if I look at this top set, we have lines that intersect right here. So that means, in this case, the top and the bottom will be the same. And you can see that they're both that hot pink color. Angle 2 and angle 3 are vertical. But we also have the acute ones, 4 and 1. Angle 4 and angle 1. And then on the bottom set, again, you have the lines that cross. You don't even have to have parallel lines cut by a transversal. You just need 2 lines, 5 and 7. Angle 5 and angle 7. As well as angle 8 and angle 6. For the next one, it says L and M are parallel. The measurement of angle 5 is 153. So it wants you to find all measures of the angles. Anything in this hot pink color is going to be 153. And then we have linear pairs. 1 and 2 together make a straight line. 1 and 2 together make 180. So we can say 180 minus 153, and that will give us 27 degrees. So that means all of the acute angles would then be 27 degrees. For the last one, it's a different situation. We are going to look at the equations given to us. So it says if L and M are parallel, the measurement of angle 6 is 2x plus 7, and the measurement of angle 8 equals 4x minus 23. Find the measures of all angles. So let's focus on angle 6 and angle 8 and see what they are to each other. 6 and 8 are going to be right here, and those are both that yellow. They're both acute, which means they are the same. So whenever you set up to find the answer to this last piece, these are the same, and the same means that they are equal. So then you would solve. Pause the video and see if you can solve. You moved them the other way, you would have negative 2x equals negative 30. And when you divide, you would divide by negative, so you would end up with the same answer of a positive 15 that I do. And then it says to find all of the angles. So x is 15, but that's not the angle. So if I do 2 times 15 plus 7, 30 plus 7 is 37. So if we have angle 6 is 37, that means that we would put 37 in this spot. And when we do our zigzag, we have 37s in all of these places. To find the other angle, we again remember that we have a linear pair or a linear pair this way, and linear pairs together make 180. So you have 180 minus 37, and then that way you can subtract and you would get your 143. So that means all the other angles are 143 degrees. And so you know also, if you go backwards, whenever you have this situation and you have this zigzag, then you know that those lines would then be parallel. To review our trig ratios, we have sine is going to be opposite over hypotenuse, cosine is going to be adjacent over hypotenuse, and tangent is going to be opposite over adjacent. On this worksheet, you are going to have to draw the picture to interpret what you have and what's missing. So we have a ladder is leaning against a wall. So we're going to draw a wall, and then we're going to draw a ladder leaning up against it. And it says the foot of the ladder is 7 feet from the wall. So that means the measurement that we're doing for this piece that I'm underlining now in this orange color is we have the foot of the ladder, so the foot is at the bottom, is going to be 7.5 feet from the wall. The angle of elevation is 73. So if we extend this, elevation is going to be from the ground going up. So this angle right here is our angle of elevation, and that says that it's 73. Now this picture is not drawn to scale, it's just going to give us an idea of where our numbers go. The question is, how high up the wall does the ladder reach? So we are trying to find out this right here, x. So we go back to our trig functions. We have so, ka, toa, and so we need to decide which one we're using. From our angle is located right here. We have all the way across, which would then be the opposite. And then we also have right next to it, and so that would be adjacent. So when I have opposite and adjacent, that's going to be tangent. So we're going to say the tangent of 73 equals opposite x over adjacent 7.5. You will need to finish solving this so that you can find your answer for number 1. The top of a 20-foot ladder touches a point on the wall 18 feet above the ground. So again, we have a wall, building, whatever. We have our ladder. Oh, that's a funky ladder. We have our ladder, and we know that it's going to touch this time right here, 18 feet. To the nearest degree, the measure of the angle the ladder makes with the wall. So what we're looking for is where the ladder and the wall meet right here. We have that the 20-foot ladder, so that means that right here is 20, because that's talking about the length of the ladder. And we do have our right triangle. If we use the ground, we now have our right triangle, so we can use our trig functions. We are trying to find this angle. So again, you're going to do SOHCAHTOA, and you're going to look at what you need to use from the angle x. If you have this side, which is across from your right angle, so your hypotenuse, and also this side, which is right next to it, adjacent. So you will then set up your equation and then talk about solving. Remember that the directions say that you're going to round to the nearest degree. The question before was rounding to the nearest hundredth. Remember that after your decimal, the second place out is your hundredths, but you do have to look at the third place to determine what happens in the hundredths place. For number 8, from the top of a cliff, so we have our cliff, and it says that the cliff is 90 feet high. So if we drop off right here, that means this is 90 feet high. And then here's the ground. The angle of depression of an object on the ground measures 40 degrees. So if we continue this cliff, it's going to be parallel with the ground. The angle of depression is going down. So what that's doing is from here, it's going down, and that says it measures 40 degrees to an object on the ground. So whatever object we have is here. So this is what we have. Now you can look at this a couple different ways. You can find the missing angle up here because together those make a right angle, and so you can subtract. Or you can also use parallel lines cut by a transversal, and so you know that this angle also would be 40 degrees because they are alternate interior angles. So either way, you can either find that missing angle to equal that 90, or you can use alternate interior. To find to the nearest hundredth the distance of the object to the base of the cliff. So right here, we're going to go, this distance right here is going to be your x. So in our triangle, we have that this is 90, we have that this is x, and we have that this is 40. So whenever you're doing your SOHCAHTOA, to determine which one you want, from the angle, we have the opposite over the adjacent. So that one's going to be tangent. So you can say tangent of 40 equals 90 over x. And again, you would then need to solve, and it's rounding to decimal places. So use that third to determine if you round. If you need to finish your work from yesterday, you can use this class time to do so. Answers are due tonight, and then the assignment will close for yesterday's assignment. Today's assignment, technically due tonight also, but again, that assignment will stay open, and you can see that whenever you open it in Schoology.